Hi, my name is Miguel Renom, and for this video I'll present work I made in collaboration with co-authors Baptiste Caramiaux and Michel Beaudouin-Lafon, introducing interaction knowledge to understand the mechanics behind digital tool use. Recently, we picked up the observation that humans possess the ability to repurpose tools, that is, to use tools for tasks for which they were not designed, and used it to show that a similar phenomenon can occur with digital tools, where, for example, someone may use a video conferencing app to create a presentation with a video of themselves embedded in it when it's not designed for that specific use case. Another fundamental observation is that tool use and repurposing, besides manipulating the tool, requires knowledge of how objects interact with each other. For example, to know that a knife has properties that let it be used as a screwdriver. In this regard, the technical reasoning hypothesis posits that tool use in humans is supported by our ability to reason about these object interactions, based on abstract knowledge of physical principles and of object properties, namely mechanical knowledge. This is abstract knowledge in the sense that we understand it through using it, like knowing that objects can fall without necessarily understanding the law of gravity. Recently, we presented evidence that users constrained to perform unusual uses of text editing tools can elicit a reasoning process compatible with technical reasoning. Participants of these studies were able to point at their past experiences with other digital environments as driving their actions and unusual uses of tools, thus pointing at a sort of mechanical knowledge of the digital world. This brought us to characterize this form of knowledge in the context of digital environments, what we call interaction knowledge. We then define interaction knowledge as the abstractions of interactions in digital environments, forming the basis for the principles or laws of the interaction in the digital world, which users acquire through experience in digital and physical environments. For instance, arguably any computer user will recognize that text input is available at the side of a blinking cursor, yet this could be seen as nothing more than a convention that became an interaction principle. We situate interaction knowledge alongside previous work such as natural user interfaces, which leverage human abilities in interaction design, notably reality-based interaction, as well as analogical reasoning, drawing from our cognitive ability to transfer knowledge to novel situations through mapping from past experiences. So in this work, we ask how interfaces affect what interaction knowledge users will use, or in different words, how cues provided by interfaces will influence users to apply a certain interaction knowledge that they possess to interact with its digital objects. With this in mind, we designed a simple editor whose objects are both text and graphic elements at the same time. The editor has two toolbars whose tools and layout mimic those of classic text editing and graphic editing applications. The setup allowed us to control the visibility of these toolbars so as to show only text tools, only graphic tools, or no tools at all. We first hypothesized that the first presentation of the environment would prime the user's interaction knowledge, that is, that having a text toolbar would prime the user to interact as text, while a graphics toolbar would prime them to interact as graphics, codenamed our priming hypothesis. And second, we expected participants to elicit technical reasoning when finding ways to optimize their use of tools to complete tasks, that is, to reason about what tools to use and how to use them, our reasoning hypothesis. We reunited 36 participants who were equally split across 3 groups. Each group was introduced to a different version of the setup. The text group saw only text toolbars, the graphic group saw only graphic toolbars, and the control group saw no toolbars. In the first part of the protocol, all participants were asked to describe how they would leave all the elements in the canvas in a selected state. But only the first text and graphic groups were asked to perform the selection, where they would receive feedback according to the toolbar that they had been presented, that is, text highlighting or rectangular selection depending on the group, as you can see there in the animations. In the second part, all participants met the system with both toolbars enabled and were asked to perform 5 tasks, each representing an increment toward the last one, each task also having varying difficulty levels depending on the choice of tools that the participant made. During the whole session for each participant, we captured their screen, their voice for the verbal protocol, and logs of their editing actions using the setup. From the results, We first observed that the choice of tools across tasks had a significant association with the cues provided for the group. Here we have 3 bar charts, one per group, each having on the vertical axis the number of participants that use either only text tools, a mix of text and graphic tools, or only graphic tools, per task in the horizontal axis. As we see, the text group used mostly text tools in all tasks. The graphics group used mostly graphics tools except for tasks 3 and 5, while the control group showed no significant preference for any tool type. This offers support for our priming hypothesis. On the other hand, we had a few participants who deviated from our priming cues, alternating tool types during tasks, some even inadvertently, such as cases where a sudden switch to use the fill tool would occur and the participant would not notice that this made no sense in a text editing environment. This happened as a way to find optimal ways to complete the tasks, as well as recognizing tools rather than the fact of being in an environment where those tools would not be available normally. And this was mostly guided by their preferences, but also by their habits, such as the fact that they would work using graphic editing environments or text editing environments, and therefore would choose tools that suit them best. So going back to our original question, how did interface cues affect what interaction knowledge was used? Well, we have on the one hand that most participants seem to have been primed by our interface cues, that is, they used either text or graphics interaction knowledge through the use of text and graphics cues respectively. And on the other hand, some participants elicited uses of tools that deviated from this priming, some seemingly unaware of a specific type of environment behind, solely based on the effect that they wanted to produce or what felt more comfortable to use, eliciting then alternative forms of interaction knowledge. So to put it all together, in this presentation we introduce interaction knowledge as the abstractions that users accumulate to form the principles of the digital world. We explore this knowledge in a simple WIMP interface where we saw participants elicit interaction knowledge both by priming them and letting them use tools at their disposal. We believe that interaction knowledge serves to characterize the knowledge we transfer between digital environments. Notably, this is useful for technical reasoning in digital environments, for example, when repurposing digital tools by principles we have learned and the characteristics of these digital tools. And ultimately, we expect this to offer support for leveraging human cognitive abilities in interaction design, such as that behind our use of tools. That concludes this presentation, and if you have any questions, feel free to reach out to any of us.